So I wanted to create a video example for something that you'll be asked to do in the homework, which is to sort of work backwards. You're given the graph of a trig function and you're asked to write the equation. And in your homework problem, you'll be told that the graph, or the equation rather, is going to have the form either y equals a sine of bx or y equals a cosine of bx. So the first thing you need to do is decide, is this a sine function or a cosine function? And also keep in mind that, so the transformations that we're allowed to apply in our equation are, well, we have this multiple a out front, which is going to affect the amplitude. And hang on, I'm writing with my mouse right now, which is not a good idea. Switch to the writing tablet. So a affects amplitude. Let's see if I can get this to work. There we go. Amplitude. And the value of b affects the period. So we can change the amplitude, we can change the period. What we can't do is apply a horizontal shift, a phase shift. If there were going to be a phase shift, then you would have the option of something of the form a sine of bx plus c. You'd have to have plus or minus a number here to correspond to a horizontal shift. Okay, so when we're choosing sine or cosine, the thing to note is the function starts at 0 and goes down from there. Your parent graph for just regular old y equals sine x, the parent graph looks like this. It starts at 0, goes up to 1, back to 0, down to -1. If your parent graph is y equals cosine x, that graph looks like this. It starts at 1 at its maximum, goes down to 0, and then the minimum at -1, back to 0, back to 1. That's your typical cycle for y equals cosine x. So this graph follows the pattern of a sine function and not a cosine function. Now I know it's going down first instead of going up first, but so that corresponds to a reflection, a vertical reflection. It tells me that the value of a is going to be negative. So we're going to use the y equals a sine of bx template for our equation. And we know that the a right here is going to be negative because the graph is going down first and then up second. It's like we took this graph and we reflected it like this to get the graph that we're looking at in red. Now, as I mentioned right here, the other thing that the a does is it affects the amplitude. So notice that instead of going down to -1, the typical minimum for a sine graph, this thing's going all the way down to -3. And then when it hits the maximum, that maximum value is +3. So the amplitude, because the graph is going down 3 and up 3 from the midline here, kind of the sea level for this sine wave, then we know that the amplitude is 3. So the amplitude is 3, and the graph is reflected. It's going down first and up second. So this a here is going to be -3. So far we've got y equals -3. Now sine of bx. The way that we should find b is to use the period. So remember the formula for finding period of a sine or cosine graph is it's 2 pi divided by b, where in this case, I'm getting a different color. I'm not sure what this does. Oh, no, I don't really want to do that. Sorry, guys. I don't usually use Word to make these videos. Okay. Period is the overall length of the cycle. So we've got one cycle going from here to here. So one cycle starting when x equals 0, ending when x equals 5. You can't really see the 5 underneath there, but that's what it says. So the period for this graph is 5. And now we've got an equation that we can use to solve for b. So we know that period is equal to 2 pi divided by b. We can see from the graph that the period is equal to 5. So we just need to solve this equation. So what I would do to solve this is multiply both sides times b to get that b out of the denominator. So now we have 2 pi equals 5b, and then divide both sides by 5. So b is equal to 2 pi over 5. So I went ahead and replaced the b right here with 2 pi over 5. And this would be the function that you would want to input as your answer in your homework.